My name's Jesper. I'm from Amsterdam. I'm a design engineer, I suppose. I am also the creator of Mannequin. Mannequin is a mockup editor which I built a while ago. It runs fully in the browser, and I'm trying to sort of reinvent how we make mockups and how efficient we can be in making mockups. As I said, fully in the browser. It works with videos, static images. We have a huge library of devices, clothing, prints, all sorts of things. Export directly from here. Get some photo filters, so you don't have to go back into Photoshop, because that's kind of the whole idea. Super fun. Anyway, I'm not going to talk too much about this. Just to highlight a couple things, to highlight my principles in designing and engineering. I really want my products to be as easy to use as possible. So one of these features is their dynamic color picker. So whatever you drop into this mockup, it will extract the dominant colors of your design and already present them to you, so you can fill the rest of the product with the colors. I got some tools here that help you to edit in real time on the product itself. So instead of moving sliders in little nitpicky little sliders, you can scale, drag, rotate directly on the mockup itself. And in terms of inserting media, I love this sort of just drag it into the slot. But I know not every brain works the same, so there's actually 5 ways to insert media through a shortcut, context menu, a little menu, pasting, dragging, all sorts of ways. So it's a principle. It's simplification through addition. It's a bit of a contradiction, but it's a principle I really enjoy. And even in this carousel, I go really into the nitpicky details, because I really want this to be scrollable, draggable, super efficient, super smooth. And this is actually what I turned into a library, and I released like a month ago, I suppose. You're like, why would you read another carousel library? Because there's tons of them, right? Who has used one of these? Yeah, everybody's implemented carousel. And why did we do it? Because we want it to be draggable, right? And we want snapping, we want all the cool things. But one thing I don't like about these is that they take away scrolling. And they override the scrolling. We get so many cool features these days, like position sticky, we get scroll snapping, and as Interrupt 2025, we get full scroll-driven animations as baseline by the end of this year. Anyway, for me, this started as a proof of concept over 2 years ago. Like, what if we use native scrolling as a base, and we apply a little bit of JavaScript to add dragging on desktop to this? And this turned into Blossom Carousel. Fully native scrolling, supports scroll snapping, all the good stuff, and is fully draggable with proper physics and rubber banding and all the good stuff. So I kind of want to break down what's behind the scenes, because it seems simple, but I managed to extract this down into like 30 slides. So let's go. First off, we know this. Scrolling, that's it. On mobile, touch devices and scrolling is dragging. This is already a valid carousel. But on desktop, we can't drag. So we want that. Right? That's all we need to do this. On to the next. Scroll features, right? We get position sticky, like I said. We get snapping out of the box, scroll-driven animations. And we want to maintain that. What all the other libraries do, they override with transforms and complicated stuff. So you don't get any of the native features anymore. So I wanted to maintain this. And so what I did, I added a little bit of JavaScript to add dragging by setting the scroll to. So we're still applying native scroll through JavaScript, and that way we get dragging. What was problematic there is that we didn't have momentum. So we can add this by enabling a ticker, a request animation frame, and interpolating or drag value over time the moment we release. Who's familiar with the LERP, linear interpolation, right? Damping. It's pretty much just the linear interpolation, but frame rate independent. We're probably here on 60 hertz. My laptop is 120 hertz. So if I were to simply do lerping, whatever I see in my laptop would run or would resolve twice as fast. So this one we add in delta, which just computes by, it's just the difference between the previous and the current frame time. And now we get really smooth frame rate independent interpolation. So that's kind of how that works. And now when we start scrolling, we need to disable it again. A little caveat on that one though. You would think let's listen to the scroll event, but since we're using scroll to, our dragging would also execute a scroll event. So instead we'll use the wheel event. And we do a keyboard event as well, because we also want to disable the ticker. Otherwise, the ticker would just be overwriting the scroll value constantly. So we've got to be a little smart about that one. Then we can add snapping. And snapping, we know in CSS, it's one line of CSS, and we have snapping. But in JavaScript, now if we apply the scroll to, that's going to resolve immediately. This was probably one of the hardest pain points of the carousel library, to resolve this one. So what I did is the moment I'm going to start dragging, I override the CSS styles. So I literally just disable scroll snapping, and I implement a JavaScript version of scroll snapping that I wrote. And the moment we start scrolling again, the CSS snap will take over. This is a bit of a simple breakdown how JavaScript snapping works. Projection is a really tiny little function, but it's really cool. It's like, it looks into the future. Projection tells you exactly where the scroller is gonna end up when the velocity resolves to 0. So the moment you release your cursor, we can calculate our ending destination, and with that we can look up our nearest snap point, figure out our new distance we want to travel, and update our velocity so that our carousel is going to end up exactly where it has to be. But now we need snap points. Where are we actually going to snap? So we got to compute them. CSS does it obviously in the browser. We need to do it manually. First of all, we're going to check, does our scroller actually have scroll snapping? If not, we're not going to care. We'll just skip. If we have snap points, we're going to traverse our scroller because scroll snapping elements are not limited to direct children. So we need to go all the levels through to find our snap points. We're going to check whether the element has a scroll snap align of either left, center, or start, center, or end. If that's the case, we'll add it to an array, and then we'll compute the offsets of the actual elements in our carousel. We're going to filter out some duplicates. We might have a grid set up with multiple rows where they all line up. So that's just a bit of overhead we don't have to care about. And then that works. Okay, this is virtual scroll. This is probably not something you're going to notice here. But what happens with scrolling, this actually has to do with pixel densities on monitor displays. Like this display might be 2280 pixels wide, but the software reads it as 1440. So it's a pixel density of 2. And if we're gonna simply linear interpolate from our current scroll left, we're just gonna read integer values. So anything 1, 2, 3 to 1440, while we actually want to have these floating point values to interpolate over all our pixels. So when setting scroll to, you can apply these floating points, but when you're reading a scroll left, it will always return you an integer. So just for that reason, I'm using an internal value to store the virtual scroll, just to get smoothing. Then add some rubber banding, just when you're at the end of a carousel, like Steve Jobs, right? a little rubber banding. This actually just applies a transform to the container, so just some CSS transforms. This is the only custom event that Blossom Carousel exposes. It's the overscroll event. This one runs on Blossom Carousel as well, but obviously in this case, I wanted to implement my own overscroll effect, so preventing the original one and overriding with a new one. There's always this issue in carousels when there's a link in it, right? You drag, you release, and it activates a link click. So there's a simple little function built in to prevent this from happening. A check whether you have dragged at least 10 pixels, and then we'll prevent any click from happening. There's a little accessibility line that's built in, so you can render your carousel as any elements you want. It's good to have an ordered list for carousel for accessibility. There's some lazy loading built in, because like we saw in the beginning, just set an overflow and this already works on mobile devices, because we don't need dragging. Dragging is scrolling. It's only 2.2 kilobytes, but why load it if you don't need it, right? And looping is a bit of a proof of concept at this point. Kind of works. It doesn't really work with snapping, unfortunately, yet. There's a couple caveats I need to work on this. What if there's not enough elements? We're still scrolling, or too many. There's a bit of a debug view where you can see the red cards actually have a transform to it. So when they're like really off the screen, it sort of puts them back at the end with a transform, and the moment the scroll bar reaches the end, it's just gonna reset its scroll value to the start and vice versa. So that way you get a looping scroll container with native scrolling. All right, that's already all the steps. This project is open source on GitHub. You can use it. I have a component for React, Svelte, Vue, web components. You can download the core itself, so you can wrap it in your own library or whatever. So please shoot me issues like this guy did, which I resolved. He asked for buttons. One thing I forgot about, once I start dragging, the ticker starts, and I only clear it when I start scrolling, or keyboards. But now it only also clears when a scroll to is called from an external state. And this, I wanted to actually extend the scroll to, but TypeScript was giving me a lot of issues on that. So I'm just keeping track of an internal, scrolling internal state. And when it's called externally, it will clear the ticker. So yeah, check it out, install it in your projects. Go to blossomcarousel.com, go to Mannequin.app, and find me here.
Stress testing, what happens if you throw like 2,000 elements in there? Does it still?
2,000?
Yeah.
Just add some content visibility to it, I suppose. Yeah, virtualization. I don't do, like, since it's all based on native scrolling, and you can use all native events, all native CSS. So I tried to keep it as minimal and bare bones as possible. So if you want to add 2,000 slides, yeah, you can figure out your own way to make that perform. Definitely. Yeah.